sit down,
No,
okay?
actually, I miss you. I miss you. Nah, I'm just playing. I miss you. No, I missed you. Remember, I came so much. I was actually so bad. They don't need a climb. It's asked, like, should I put a question mark next to it? Oh!
You guys, I won't show it, but you know the CPCTC things? It raised people's percentages like 2 points. So like, so if you're at a 91%, you could move to a 93%.
Can you just pretend like this part's not? I had a different theme and then I changed it, so just pretend it's not there.
I wouldn't have even noticed. You're all good.
What did you do? You pick with cheer to celebrate. No. Just follow it.
Alright guys. So, when we go over this, make sure that you are following along. And feel free to answer more than just Maya, because that puts a lot of pressure on her.
What? Can I use the graphic?
But I just feel bad for you sometimes, because you have to answer a lot. Okay, so what we're gonna do today is we already learned the 4 ways to show that 2 triangles are congruent. But what we're gonna do today is we're going to use all 4 of those in proofs. So if you guys remember what we have side, side, side. We have side, angle, side, where the angle has to be right in between the 2 sides. And then last week, we learned a new one, which was angle, side, angle. And remember when we did this one, the side had to be right in between the 2 angles, okay? So then we also learned on Friday, angle, angle, side. And this was the one where the side was not in between the 2 angles. So if the side is between the 2 angles, it's angle, side, angle. If the side is not in between the 2 angles, then it's angle, angle, side, okay? By the way, I should ask you guys this too. So I was gonna spend 2 days reviewing for the quiz. Would you guys rather do 2 practice quizzes where you do it on your own and ask questions? Or one of the days, would you rather do like kind of a review activity together?
2 practice quizzes.
Everybody feel that way?
Uh-oh.
All right. Okay, so let's look at this proof, and like I said, please pay attention today, take notes, so that you know how to do this when it comes to your quiz on Thursday. Now, I have 2 givens, okay? One of them is LM is congruent to NO. So when I come down here, do you guys all agree I would write given here?
Yep.
Okay. Then I have 2 angles that are congruent, and that's also given. So I'm going to come right here and write that. Angle M is congruent to angle O, and that is also given. No one in this class should get givens wrong. Okay, those are free points. Now, what we're going to do is look at that and see if there's something else that we can mark. Vertical angles. Are you guys getting to a point now that you can see vertical angles? When you have two lines that intersect, it would be like this angle and this angle that are across from one another. So you always want to be looking for vertical angles. So I'm going to say angle MPL or LPM, whichever way, P just has to be in the middle, is congruent to angle NPO or OPN. And again, P has to be in the middle. Now, Maya had said this was vertical angles, and remember on your cheat sheet, if you open it up, it has those common steps. What is the step for vertical angles? Vertical angles theorem. Do you guys want to all take out your cheat sheet really quick so you have that out? And then we can open it up to that. And then I just want to remind you guys too, a week from tomorrow is the last day of the try. I probably shouldn't do this, but I will accept late work up to next Tuesday at 3 o'clock. And if your grade is not at 60% or above next week, then you have to retake the class, okay? So, just so you guys know. All right, now what I'm going to do, I did the vertical angles theorem, and now remember that last step, and this too, everybody could do, even if you have no idea how to do proofs, you all could copy this down on the last statement. And then when you get to that last step, these are either gonna be side, 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 angle, side, angle, side, angle, or angle, angle, side. Which one is that?
The last one.
So yes, it's one of these two, and because the side is not in between the two angles, it's angle, angle, side. The side's in between, it's angle, side, angle. If it's not in between, it's angle, angle, side. Okay, now let's go here. And we have two givens again. So the first one is that BD is congruent to BC, so that's given. And then we have that these two are parallel, okay? That given we can copy down onto step 2, okay? And that's given. That is also marked. Remember, this means parallel, and how you mark it is with arrows on those sides. Now, when you guys look at this, if you have arrows, that means parallel lines. What do we look for? Alternate interior angles, okay? And they're telling us which ones they want us to mark congruent here. So what they're saying is they want us to say D and C are congruent. Are those two alternate interior angles?
What? Oh.
D and C. And if you look, thank you. So if you open your cheat sheet up like this, alternate interior angles theorem is right here. So if you have that open, you should be able to see all of those common steps. Okay. Now they're saying angle ABD is congruent to angle EBC. Well, ABD is this angle, and it's congruent to EBC, which is this angle. aren't those vertical angles again? So we go here, and it's vertical angles theorem. Okay? Now, notice what we're trying to prove is we're trying to prove that these two are congruent. Do we have enough either by side, angle, side, angle, or angle, side? Which is this?
Angle, side, angle.
Yep, angle, side, angle. So I come down here, I bring this down. So it's gonna be triangle ABD, and again, anyone can bring this down. That is not something you should lose points on. And then here you have a 25% chance of guessing, but because we have two angles and a side, that tells me it's one of these two, okay? Because the side's in between the angles, it's angle, side, angle. Okay? Now, let's go here. And so the first step is given again. And that is that JK is parallel to MN. Okay? And notice it's marked here. Okay? Then they tell us that JL, which is right here, is congruent to ML. That's also given. So that I'm going to copy down in the second step for given. Okay? Now, the third step, they want us to say that angle J is congruent to angle M. How can I say those two are congruent? They're alternate interior, and I can only do that because these are parallel, okay? So alternate interior angles theorem, okay? Now, they want us to do alternate interior angles theorem again. Do you guys see two other angles that are alternate interior? K and N, very good. So these two are parallel, that makes both sets congruent. So I can say angle K is congruent to angle N because of alternate interior. And now we're going to go to the fact that these two triangles are congruent. And which one is this by? Yes, you don't use the parallel arrow when you're deciding. You have two angles and then a side, so it's angle, angle, side. If the side is in between the angles, it's angle, side, angle. If the side is off, like after the two angles, then it's angle, angle, side. So we're gonna copy this down, triangle JKL is congruent to triangle MNL, and like we said, angle, angle, side. Okay? Now let's look here. We have one that is a bisecting one. I doubt that this will be on your quiz, because this isn't a super common one. But on that cheat sheet that you have, we do have a step with a definition of segment bisector, okay? So if you have one segment that bisects another segment, that means you're gonna use definition of segment bisector. It says AE bisects BD. So that means it cuts BD in half. And we're gonna have that step. So what they tell me first for my given is that angle B and angle D are congruent. So this first step is given. Okay. Now for some reason, then they write the first given up here as step number 2. but that's another given. And those are two things no one should ever get wrong, okay? And on a test, I give you guys 2 points per step. So this is 4 of the 10 points that you would get just by writing those givens, okay? Now, it says BC is congruent to DC, and how I can tell that is because of this. AE bisects means cuts in half, BD. So these 2 pieces are equal, and that is definition of segment bisector. Okay, that is on your cheat sheet, and you have to use that anytime that you have the word bisect in a given. You're gonna have that step. Okay, now it says, how can we say that angle ACB right here is congruent to angle DCE right there? Those are vertical angles again. When you have straight lines, the ones across are vertical angles theorem. Okay. Now, we have the proof statement written down. And what did I not do? Oh, I never marked B and D at the beginning. Sorry about that. That was one of our givens, and I just never marked it. Now, what is this one?
Angle side angle.
Yep, this is an angle side angle. The side is in between the 2 angles. So what I would write here is angle side angle.
Is this all just review today?
Kind of, yeah.
Or are we learning?
Looks like we're doing a ton of proofs. Sorry. Okay. However, hopefully as you guys are seeing these, then you're starting to recognize more of the common steps. Okay? So bear with me. So PR is congruent to TR, and then angle P is congruent to angle T. So those are our 2 givens. And you guys are gonna love this because we get to do this one all by ourselves, okay? So, step 1, PR is congruent to TR, I think it was. And then P and T are congruent. Now, when you have 2 things congruent like that, you can do 2 steps. You'll notice that where I get these problems from, they do 2 givens. I typically just do 1 given and put them both there, but you're welcome to do it either way. Now, when you guys are looking at this, do you see something else I can mark?
Vertical angles.
Dawson, can you pay attention?
And also, why does it say for the proof, it says like ABC and DBC, but
Yeah, that is a typo that are on some of these, and then I always forget to go back and fix it. It should say this. Thank you for pointing that out. Okay, so does everybody understand those are vertical angles? And when you're doing the vertical angles, you have to label it with 3 letters. So I'd go angle PRQ. So for step 2 here, I can do angle PRQ is congruent to angle, and that would be SRT. And then, like Maya said, those are vertical angles. And what do we put at the end of that?
theorem.
Theorem. If you have your cheat sheet opened up, you'd be able to tell that. Now, are we ready to say these 2 triangles are congruent?
Yeah.
Yes.
Angle side angle.
Angle, side angle, very good. So what we would do is come down and copy this down. Like we said, that was a typo. So we'd say triangle RQ is congruent to triangle TRS. And like Maya said, this is angle, side, angle. So when your side is in between the two angles, then it's angle, side, angle. Angle, side, angle. Okay? All right, let's look at this one. We have two givens again. So let's write those down. We have AB is congruent to ED. And we have that angle A is congruent to angle D. Both of those are given, so I'm going to put them both under step 1. Okay. Do you guys see something else that is congruent?
Vertical.
Vertical angles. How many letters do I have to use to
3.
say? 3. Okay. So I'm going to say angle BCA is congruent to angle DCE. And those are vertical angles theorem. Okay. Then, am I ready to say that those two triangles are congruent?
Yeah.
Yeah. What is this one by?
Angle side. Angle side.
Yeah, 2 angles and then a side would be angle, angle, side. The side is not in between the 2 angles, so it's angle, angle, side. So I'm going to copy this down. Okay. I'm going to say triangle ABC is congruent to triangle DCE, and that is by angle, angle, side. Okay. We have 4 more. All right. So now we have 2 givens again. And so I'm going to write those down. What do those vertical 2 lines mean?
They're parallel.
They're parallel. Very good. Okay, really, truly, these should have segment bars on them. Okay. Are the parallel things written on the diagram? Are they designating those lines are parallel? So what do I write? How do I show parallel?
Alternate interior.
Yep, they are going to be alternate interior, but what would I put on these 2 lines?
An angle.
Not an angle, what, arrow. Do you remember that? Parallel we draw with the
You have to do
triangle. Yeah, you should.
What if you forget?
Well, as far as like on the quiz, I grade this, but the arrows might help you remember to look for alternate interior.
Because I use. What if you use no, you're supposed to use?
Then you're fine. Then you're fine. Okay, so when you see parallel lines, we want to look for angles that are alternate interior. When they put an angle 1 and 2 in there like that, that's to help you name the angle so you don't have to use 3 letters. So what we're going to say here is because these 2 are parallel, this angle is congruent to that angle. So I can say angle 1 is congruent to angle 2, and that is due to be an alternate interior angles. And do you guys know what comes after that? Alternate interior angles theorem. Okay. Now, do I have another set of angles that are congruent here? 3 and 4, because these are parallel. So angle 3 is congruent to angle 4, and that is also by alternate interior angles theorem. Now, had I wanted to, you guys, since these are the same, I I really could have put both of these under step 2 and just had one step that was alternate interior. Now, does anyone see something else that's congruent? Reflexive. So the arrows never count when you're deciding side, 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 side angle, side. The arrows don't count. So I had 2 angles, but I needed a side there too. So we're gonna do reflexive. AC is congruent to AC, and that is reflexive property. Okay. And now, do I have enough to say the triangles are congruent? Yeah. So I'm going to bring this down. And yes, you're right. It's angle, side, angle. And it was triangle ABC is congruent to triangle CDA. By angle, side, angle, because we don't look at the arrows, we look at this angle, that side, angle. The side is in between the 2 angles. Okay? Let's look here. We have another one that has a step that we haven't talked about yet today. So let's write our given. And again, truly, there should be bars on this. So segment AB is parallel to segment DE, and that's given. And remember, when you have parallel lines, you're going to go to those lines and draw the arrows and look for what? Alternate interior. Now it says C is the midpoint of BE, which also should have a bar over it. Now, midpoint is one I did not talk about yet today, but it's one we have talked about. It's the second one down here. If you see the word midpoint, you have to use midpoint theorem anytime you see the word midpoint. So it's telling me C is the midpoint of BE. That means these 2 pieces are equal. Midpoint means middle. So now I go down and I say for step 2 that segment BC is congruent to CE, and whenever you have a midpoint, you're going to use midpoint theorem, which is on your cheat sheet. Whenever you have a midpoint, you're going to use midpoint theorem. Okay? Now, we can't just use one set of sides, so I have to add to that. What do you guys see here that I could still say is congruent?
AC, CD.
We are saying these 2 sides.
Wait, that's the midpoint?
Okay, really good question there. C is not the midpoint of AD. It only says C is the midpoint of BE, so we can't mark those. Vertical angles, that works. We have to use 3 letters there, so I can say angle BCA is congruent to DCE. BCA is congruent to angle DCE. Okay, and that is vertical angles what? Theorem. Very good. Then I need one more thing. And honestly here there's 2 separate things we can mark. We only need one of them. And the one that we choose is going to determine which way our triangles are congruent. This particular proof, we have 2 different ways to prove it, okay? Do you guys see anything else I can mark? When you see the arrows, what are your alternate interior? Do you guys get that B and E would be congruent because they're alternate interiors. But wouldn't A and D also be congruent?
Yeah.
Do you guys get that? The one that you choose is going to affect the way that you're showing those triangles are congruent. If I choose B and E, okay, I can do it that way. So let's do that. Let's go down and say angle B is congruent to angle E. And that was because they were alternate interior angles theorem. Okay? But when I pick B and E, what way am I showing that these are congruent? This is a what? Like as far as side, angle,
Oh.
side. This is a
Angle, side angle.
angle, side, angle. So I can go down and write this down, okay? And then do triangle ABC and DEC. Okay, and that is going to be with these, okay? Those triangles are congruent by angle, side, angle. Angle, side, angle. So this is angle, side, angle. However, I just want to show you something. You don't have to change yours, but if we had changed this and instead we did angle A and angle D, then which one would this be? Is the side in between the two angles? It's not, right? So this one would be angle, angle, side. A third way this could have been done is we would not have used vertical angles and we would have just done B and E and we wouldn't have done these vertical angles, and that would have also worked. But when you look at this angle is in between those two sides, or this arrow, sorry. That arrow isn't used to say that triangles are congruent. So it's two angles and then a side, so it's angle, angle, side. So again, how you label this would have more than one answer. I'm gonna just put it back to where it was when we started. So this one actually has 3 different ways. And if that was on a test, you would just do one of the ways, and I would know that you have more than one way, and then we would be good. Okay? This one I think you guys can do, so should we skip this one? Okay. And then let's look at this last one. Let's do this one. Okay? So I have 2 givens. DE is parallel to FG. And angle E is congruent to angle G. That is given. Okay? Now, notice for the parallel, they put our arrows there, which is what we want. When you see those arrows, what are we supposed to think of? Alternate interior. Do you guys agree it's this one and this one that are alternate interior? Because it's always the ones that touch the side that is parallel. It's the arrows that touch the side that are parallel. So I would say their angle EDF is congruent to angle DFG or GFD. F has to be in the middle there, so DFG. And that is by alternate interior angles theorem. Now, ignore the arrows. Do we have enough to say these triangles are congruent?
No.
What else do we need?
Reflexive.
Reflexive. So we're gonna say DF is congruent to DF. Which is reflexive property. And then we can copy down our proof statement, triangle DFG. Is congruent to triangle FDE by, which one is this by?
Angle on the side.
Yeah, the side is not in between, so it's angle, angle, side. So, hopefully that repetition helped you a little bit. We're going to do a worksheet that I have copied off. And then this is your assignment for today. Tomorrow you'll have a practice quiz, and then we'll get you ready for the quiz on Wednesday. I do just want to remind you, for some of you, how this quiz is going to be a lot of points. Next Tuesday's quiz is not. So a lot of you, this quiz may decide if you pass or fail. So if you need help, Dave is in the room, and then we have Miss Nelson in the room, and we have Miss Jerpsek in the room, and myself. So we have 4 people that can work with you if you get stuck.
This is so